So I would like to say just a few words about the location, because that's very often the case. People say, oh, there is Siemens in Karlsruhe, we didn't know that. Well, actually, Siemens has been around for more than 70 years here, and you see it's a pretty big area. And guess what? We have around 4,000 people working here. It used to be 7,000 maybe 30 years ago, but we are still 4,000, and only in the last year we hired another 150. So the tendency is going up again. And it's very interesting to see a little bit the history, and that's only the second and last slide I want to say, what Siemens did here in the past 70 years. You can see in the 50s, right after the war, radios were assembled here. And then later on, obviously, that was high-tech at that time. They did this kind of radio broadcasting equipment. And obviously, also the Olympic Games 1972 in Munich were equipped with Siemens equipment built here in Karlsruhe. Of course, we are not producing that kind of tools anymore. But the next three pictures are a little bit closer to our reality today. In the early 90s, the first distributed control system for power plants was developed here in Karlsruhe. And actually, we are still one of the world's leaders in distributed control systems for power plants, but also chemical plants, etc. Also, a very nice tool which was developed here was in the 90s, the alcohol analyzer, breath analyzer. And we also don't produce this equipment anymore, but we are still a producer of gas analytics. So if you will, this traces back to these roots. And then in the 80s, the first Siemens personal computer was developed and manufactured here. And actually, that's also something we still do here. We have a large electronic manufacturing. You just walked by. Around 1,000 people are working there. And we are still producing PCs here, but typically not the PCs you have on your desk, but these are industrial PCs, which you find in process plants. So in the end, the key message here is innovation was always key in this location, and the location was always able to reinvent itself and detect early on new trends and come up with new technology. What this is today, I will show you later in the company presentation. But for the time being, I think you have at least a certain impression about the location. Again, a warm welcome. I'm really looking forward to all your pitches, and let's have a great afternoon and later on also a great evening. Thank you very much. And this is the agenda. And I don't know, you don't have to clap for that. Thank you. The agenda, welcome, is now over. We would start now into the SIL. I don't know who will take over. This is you? Ah, okay. Then please get on the SIL. I'm happy to you.
Yeah, welcome everybody. Are you excited?
Yes. Yes. No, I'm sorry. Again, are you excited? Yes.
Thank you. Thank you in particular you for hosting this event and for helping us to make this real. And this was is also the starting point of our short introduction. Perhaps some ideas for those who have not been part of the first parts of the SIL, the first years. And our invention, the professor's invention, was started with one fundamental thing, and it was Carl Benz who patented his first car at the age of 41. Yeah, and well, if you look at Elon Musk, who's in the media, well, almost every day. I'm not sure whether due to his inventions, but also due to other things. You see, he was at the age of 24, and this is a quite tremendous shift over the last years. And well, this brought up a question. If you ask students today, what do they want to do after their studies, they say, well, I go anywhere and work. And this was the starting point to produce the Student Innovation Lab, to make students to innovate already during their students' life. And this was the starting point of our collaboration, fruitful discussions almost already today about these wonderful things. In particular, it's the final pitch today. It's the very end of 1 year of excitement, work, frustration, I think, but also, I hope, a lot of fun. And fun is the driving force for innovation. Perhaps I hand over to you, perhaps to explain a little bit the ideas.
Mm-hmm. Yeah, thanks a lot. So for those who don't know me, my name is Orestes Tersidis. I'm Professor for Entrepreneurship at the KIT, and it's a pleasure to be co-initiator of this program. When Søren came to me a couple of years ago, meanwhile, in the office, I think within about 2 minutes he convinced me this is a wonderful idea. And I'm still fully convinced of it and fully committed to it. So what is the thing about it? Many of you have been through that, so you know it firsthand. Some of you maybe have a first look at it now. So what is STIL about? STIL is about combining, if I say it in a nutshell, combining technical excellence and technical practical work with entrepreneurial mindset and action. That's the main idea. And how do we operationalize that? Well, we have basically 2 main streams that flow into that. One is obviously that we have the labs. This is why we call it Student Innovation Lab. So there are many professors involved, and it's a great thing that it's a broad alliance, if I may say so, that really fosters this format. So there are many professors involved. They do the different technical labs and provide the know-how, the infrastructure, the possibilities to create something, to really create a technical prototype. And then on the other side, we've got the entrepreneurial units, the entrepreneurial training. Now again, of course, you may ask, is it something you can learn? And sometimes people ask that, but I think common understanding today is, of course, there is a couple of competences that you can really learn. It's about being oriented, so you see as part of the program a lecture where you have the necessary orientation. But then it's very hands-on. Then it's very about applying this knowledge to the concepts. And by that you create specific entrepreneurial domain competences, but it is as important as these domain competences, personal competences and social competences. So personal competences means things like being able to go through a crisis, yeah, you said it, to have the perseverance and the drive to overcome the challenges that you meet. And there is no entrepreneurial project, probably there is no real thing in life where you don't meet challenges. And the important thing is not to go around the challenges, but to find ways of, or to develop strengths like resilience and perseverance and follow through to still overcome these things. So that has to do with personal competencies. And then obviously you also have to work with teams, you have to convince other people. If you pitch now, you will have to convince the audience and the jury. So this has to do with social competences. So competences in communication, in staying authentic, but also understanding the other point of view and so on. So all these things are somehow operationalized in flow. And as we hope, and you see there is parallel things, I'm not going through details here, but I give you the main ideas. There is a program that is designed to develop that set of competences and combine it with the technical.
And, well, before we come to the partners, you may have realized that there are three things which are necessary to be successful at the very end. And you have here a lot of senior managers who did this throughout their professional life, and you may have realized this during the practical part of the Student Innovation Lab seal. One is focus. Over the entire time, you might have realized it's necessary to focus on one specific idea. And with my group, I had a lot of discussion of ideas, but at the very end, and it was around the midterm pitch, to decide whether I go this direction, that direction, or that direction. You can't do all of the things. This is typical. Second is empowerment and push. You have to push it forward and to be, well, to be successful in that sense. And if you want to do that, and this is something you may have realized over the last few weeks in particular, you have to do all in, which takes a lot of time. I think you worked hard, and thank you already here at that point for this kind of engagement, passion, and enthusiasm, which, well, took place over the last weeks, which I know from the daily collaboration of the assistants and so on. But this is not possible if partners are not available. Or better to say, I want to thank very much our partners, which are named here, to how to make such a, well, untypical, I would say. It's not a typical lecture which we have at the university to make this real. And the partners will present themselves. But many thanks for helping us, and in particular, again, many thanks to host us here in this nice environment. Well, we start with the company presentations later on. Not shocked, not to be shocked, but now it's time for the first presentations, and we want to hand over to our professional moderators, Sien and Christine Eckerle. She isn't present right now, but she will. Yeah. So thank you very much, and particularly thank you very much for being here, all the participants. Thank
you. Before we jump in, I quickly want to guide you through today's agenda. After the first introduction words, I will briefly explain the SIL roadmap to all our new guests today from a student perspective. We will then have 3 company presentations. Professor Hohmann mentioned it. We're really thankful for your support, especially from a mentor side. So 3 presentations coming up right after that. And then the main part of our today's event, the team pitches of our 6 teams. Christine will guide you through these. We will finish off with 2 more company presentations, and then the jury gets to separate. They'll have a separate room to discuss who will be the winners of today. And then we have a small outlook of what can happen after SIL. One team from last year will present how they proceeded after SIL last year. Then after the winners ceremony, Siemens invited us to stay here in a neighboring building to get together and have a drink. Quickly on to the roadmap from the student side. So the teams started in November, basically with no entrepreneurial experience whatsoever. They did their bachelor study program either at the KIT or abroad. They came together here. They were able to choose one lab and then were put together in teams of 4 to 5 people. But they had one thing in common. They had the vision to create something and apply something with impact. And then within the last 9 months, they followed the SIL path. They started brainstorming, ideating, created dozens of ideas, and then narrowed it down to one paper prototype, which was presented at the midterm pitch. Since then, a lot has happened. The teams started following 2 parallel tracks, both the business modeling and the implementation of a actual prototype. And they did this in various ways with a lot of input from the outside, a lot of mentors from the research and development. They looked at their market, what they want, what problem do they want to solve, and looked at their potential customers. And yeah, really had some intense weeks, the last couple of weeks, I'd say. And today they're showing us both their prototype and their business model. And I'm really looking forward to what we're about to see. All right, then I would like to hand over to Siemens for their quick presentation, and enjoy this afternoon.
All right, I will try to make it in 5 minutes. So once again, quick overview about Siemens. Now a bit more about what we do in terms of technology. So very quickly, I mean, Siemens still is a very big company, 70 billion revenue and a few 100,000 people. We are part of digital industries, and this is where we do here process automation for process industries. For example, BASF, when you think about that, you can imagine that they need any kind of instruments, analytics, control systems, communication, etc. But also a factory like Volkswagen needs a lot of automation. That is exactly what digital industries does, also motors. I will not go in the rest of Siemens, that would take an hour probably. Today I really would like to focus a bit on digitalization. You see here our CEO, Dr. Busch, and he's talking about the importance of digitalization. And actually a lot of the pitches I think we hear today are also dealing with digitalization. So that is definitely the way to go, and I will show you how we are doing that as Siemens. Now, in the end, it's all about combining the real and the digital world, and one of the most important concepts here is the so-called digital twin. That means, of course, you want to describe what you will do later on in reality. Previously, you do it as a model, you can do simulation, you can do the engineering all digitally, which saves time and makes things also more cost effective. And that's really the clue about it. In the past, when you did all the engineering on a drawing board, you did it sequentially, you had the design, the simulation, the engineering, and it almost took forever. If you do that in a smarter way, you're kind of doing that simultaneously. And we really have very nice examples how you can cut the project times by at least 50%. Now, another very important topic here, and that's really also not new to you, is of course the convergence of OT, operational technology, and IT. So OT, this is where I classically come from, field instrumentation analytics. That's where you measure the real world analog values. But in the end, you want to bring the data into the cloud. That's the IT world. And the big task we are tackling here in industry is really to help our customers to bridge that gap, to make the data available in a cloud environment from the operational technology. That's in a nutshell what we are working every day. And you see, of course, there are different technologies, there are controllers, there are edge devices. We need to deal with cloud technologies. It's a very broad field, and this is where we need, of course, a lot of fresh ideas and new expertise. So, and one idea here is we are really defining this so-called convergence layer. It's not so easy to collect all these data which are there. You can imagine there are many, many different protocols. All these instruments are speaking different languages. Then you have, I mean, hundreds of various applications, and to standardize that in a form that our end users can cope with it, this is one of the key tasks to make the life of our customers simpler. And that is why Siemens comes up with this kind of industrial IoT concept. We call that Accelerator. That's a program which was started last year, and it is really meant to help our customers on their digital journey. It's not predominantly products. Of course, there are also products in this platform, but it is also creating a kind of ecosystem. In the end, we understand that even Siemens is not big enough to do everything on their own. And by the way, customers are not willing to only work with one supplier. That's clear. So we are working with a lot of other companies in the meantime to create this ecosystem where they can also implement their own apps, their own applications in a portfolio which then can be used by our customers. In the end, it's also about a marketplace which enables our customers to make use of all these different offerings. Well, to be a bit more specific, because we will not talk too much here about those nice gadgets you see in this process automation world. In the end, here you see everything from the field to the cloud. You see a lot of instruments. You have two models here. One is a chemical model, the other is a pharmaceutical model, where we are helping our customers to understand how they can apply all these instruments, how they can control their processes. You see here a typical setup, how an operator of a plant would work with a process plant. Okay, there is a distributed control system, there is an engineering tool. All of these things are part of our offering and are shown here on a regular basis to customers in a real life example. You can fire up these models and then you can test different use cases with them. An important part, and this is something I really want to mention, is the industrial communication. You see it on the right side. That is something which gains more and more importance. Cybersecurity is a big topic. How can you make sure that the data are really secure? Again, I'm using a big chemical plant as an example. You definitely don't want people to intrude into such a plant. And so cloud is a nice concept, but it makes you also vulnerable. So you really have to make sure that you have highest possible cybersecurity, and that is part of our communication offering here. Now, to give you a bit of a flavor how we try to shape the world, I show you a quick movie to give you a little bit the spirit of our organization. So I think that fits quite well to the SIL, curiosity, exploring new things, and that's exactly the kind of spirit we are looking for. I think we are a great team, and if you are interested to work with us, keep in mind we are always looking for good students and bachelors and masters, so reach out to us. So thank you very much, and I hope I stayed within my 5 minutes, and then I would hand over to, who is next? Okay, here we go.
perfect. Great assistance here. Looks good. Looks nice. Okay, I can start already. I have basically 2 companies to present in 5 minutes. That's a challenge, but I'll accept it. I'm Jörg Nagel. I'm Managing Director of Neoception. We are a subsidiary of Papler & Fuchs, small IoT and Industry 4.0 company. But I would start with our mother, who is the official sponsor of the SIL here. So what are we? We are a company of around 7,000 employees, just cracked the 1 billion euro last year with our sales. And we are in some areas where also Siemens is doing. So we are basically interfacing all these process industry components which you see in the back. Perhaps one? The presenter is not working after. Presentation, okay, perfect. Then let's do it without it. So what do we do? You see on the top left side some industrial components, so from 3D, 2D laser scanners, positioning sensors, up to really sophisticated camera-based systems where we are applying also machine learning and AI technologies in the meantime to improve the core competence of the sensor, so to make the sensor a bit better than with conventional algorithms. We have the explosion protection equipment on the top right side, where most probably also some cool stuff is built in here, and we could interface with a lot of Siemens components through industry standards, and that's why everything is interchangeable. And yeah, exactly. We're pushing also in companies like BASF and the like. Basically, there's a nice story of invention and curiosity. Our company is based on the invention of the inductive sensor. And how did that happen? There's a story behind. Mr. Peppel and Mr. Fuchs, they had a radio repair shack back in the 1950s. And they were asked from BASF, couldn't you build us a sensor or a switch which doesn't create a spark? Because if we have explosive environments, it could be really dangerous if we have a spark in there in our facilities. And that's basically how the inductive sensor was invented. They said, we could do some electronic circuits with detecting if a metal part is there, dampening a electronic circuit. And yeah, that's how here to the top left, top right, these cubic green sensors have been invented. In the meantime, we also gathered a lot of different companies going from Neoception, where I'm a bit located in, VMT and Polyplan, where we do full customized solutions for automotive industry, from vision-based sensors, robotics control, to polyurethane foam and wax applications. So really a broad range. And up to a company called Ecom, where we have ruggedized field devices and smartphones and tablets for the process automation industry, everything explosion protected, up to full customized mobile solutions. We basically can build you a new Google Pixel device if you want. It's still not working, so I just call you. So, and then Neoception, that's where my home turf basically is. We are a small company now, slightly above 35 people. If you just go on, please. We have 2 locations in the meantime. One location here in Mannheim. We also founded in 2019 another subsidiary in Portugal, where a lot of our developers are sitting, where we are also really well connected to the universities there. And we are driven by curiosity to optimize the business processes on the shop floor of our customers. So everything where material moves from A to B and back to a warehouse, for example, and where also information is involved, that's what we do. You can just go on. Yeah, our team, quite young people, to be honest, driven by curiosity to invent new stuff. That's also what we do for Peppel and Fuchs. So we do not only provide our process optimization solutions to our customers, but we are also something like an incubator and an innovator within the Peppel and Fuchs group. At the moment, we are building a machine learning AI competence center where we are basically sucking in all these new technologies which came up with, like ChatGPT, to improve our development processes, but also to improve in the future our products. Where are we at home? Somewhere in between IT world. We have a lot of IT experts. The hardware and all the process control, what you have in factories. And our heart beats a bit for the process optimization, as I already said. And we're basically in the middle of all this. Very, very interesting times at the moment. And if you like, you could definitely join us, call me, send me an email or ping me on LinkedIn, whatever you like, if you're interested to be part of this journey. And that's basically it. Contact information. Yeah, thank you very much for your time.
Now it's time for Vector. We need to quickly need to switch here.
So, okay, hello everybody. My name is Clemens Reichmann, I'm from Vector. We are in automotive industry and we hope to find a good, let's start. No, it's not Pepper and Fuchs, okay. Yeah, okay, so this not, I'm confused, there are two things. Okay, this is more I can do. Okay, so yeah, working at Vector, so we are in automotive and we are happy to look for good people, and so I'm here to sponsor this great lab here. And we also started in Karlsruhe with a startup, and we joined Vector, so there's a subsidiary of Vector in Karlsruhe since many years. Okay, so what do we offer here? So we are around 4,000 employees in the meantime. We have a turnover of 1 billion, which is great after 30 years of Vector. We also are a foundation, so we are the complete stuff we do. Our profit goes into foundations, like things we sponsor here. And we are committed in social stuff. We are committed in university. This is programs. We are promoting startups. That's good. If you do a startup of your idea, so Vector is also here, maybe to support you with that. Okay, and our management team is great. So we, of course. Okay, no, that's okay. So as I said, we are in automotive industry, and there we helped we have the OEMs and the first tiers. That's the people doing cars like Tesla, like BMW, like Daimlers, and so on. So we help them to bring their electronic, their software to the market. So we do not software, we do the operation system for those embedded systems, we do frameworks, but also tools. We do simulation of bus systems in those distributed systems. So we also do the design tools there, we do calibration, we do many, many, many things I've forgotten a lot of. So it would be great if you want to come to this community. Automotive is really cool, because it's the mobility of the future in any kind, and so that's it. And we help to transform this industry from the bad things of CO2 to the good things like electronic. And I'm an electronic engineer, so it's great to see that this community moves forward in this direction. Okay, so what else? Of course, we have to be a good company. That means, okay, a lot of good things here. You see, I will not mention everything, but it's very important to support our employees in their lifestyle. We also helped them to educate them during the life in Vector, and we also looked at everything is fine with them. We also asked for you. So we have 22 vacancies in internships. There are many more. We have also student works. We have the possibility to do theses here, like masters or bachelor theses. So we were happy to support you in Karlsruhe, in Stuttgart, or wherever you like to join Vector. And of course, afterwards, we have a lot of open vacancies. We have around 100 open things here where you can find a good possibility. You can also start with a trainee program. That's cool, because there you have a high ramp up in our management team. And of course, there are also possibilities to join Vector if you're not software or electronic engineer. There we have our NET program, where we bring any kind of, not engineers, but any kind of motivated students into our area, and so on. Okay. So if you apply, we are happy. So yeah, I'm 4 minutes, 40 seconds, that's good. So come to me and we can talk about that. Thank you. And the most important thing, do a great job now, do a good pitch. I know what I say because I had to do a lot of pitches when I run the startup, and it's really cool to see how you're motivated and how your results are. So I'm happy to see. Thank you.
Perfect. Thank you so much. It's amazing to see what our sponsors actually do. But with no further ado, I will hand over to Christine, who will now guide us through the pitches.
Thank you. I think that is also working. Yeah, hello also from my side. My name is Christine. I am a PhD candidate at the chair of Professor Orestes Tertsidis, and I had the honor and pleasure to teach the students this year together with my colleague Sarah Mante. And I think curiosity is the keyword today, what we heard from the established companies, but I think you're all also very curious to see the pitches today of our student teams. How is this going to work? So each team has 5 minutes to pitch. They know the drill, so I am sure they will keep the time. But if they don't, I unfortunately have to cut you off. After that, we have a Q&A of 7 minutes, and there it's up to our jury. You have to ask questions, be precise, be curious, ask a lot of interesting questions so that we really dive into the ideas of our student teams. I will have to ask that only the jury will ask those questions, but of course, our audience here on premise can ask all their questions later on when we network. And also hello to the audience online. I think we really haven't said that. Online and offline, the audience will also later be engaged because we do have a voting from your side. It's called the Darling of the Day. So pay attention. You have to vote later. The jury also has to vote for best presentation and best product. Yeah, looking forward to hear how they decide. I already know a bit, so I know it's going to be really hard. Okay, without further ado, we do have a set schedule. So we have Track Tech first, then Next, Sign Me Up, Sky Squadron, Gecko, and Desoltic. And I would ask Track Tech to come on stage. All right, over here you can see the timer.
Oh, perfect.
I will, as we trained, ask you if you are ready.
We are ready.
Okay. Jury is ready? I think so, all right. And then the 5 minutes start now.
Hello, ladies and gentlemen, and welcome to our presentation. Let me start with a simple question. When was the last time you bought something in a physical retail location instead of online shopping? The truth is, physical retail is struggling at the moment. And the situation looks more or less like this. And here's where we come into play. We want to help physical retail stores punch back. And how? By revolutionizing the retail experience through wireless security and data collection solutions. But what does that mean? When we look at physical retail stores, we notice that they have one key advantage that online shopping can never provide. And this is that they can actually offer their customers devices to try out before they buy them. But because of the clunky security devices in place today, they can't really try them out. For example, these big clunky wires that secure the iPhone to the showroom table prohibit you from really trying them out. And we developed a completely wireless and compact security system that allows the customer to have a seamless experience with those demonstration devices and really try them out, while also having a data collection system in place that collects valuable data that we can further use to increase the business of the retail stores. But how would a system like this actually work? My colleague is now explaining to you how this would function.
Thank you very much, Kai. Okay, build our first prototype around smartphones in smartphone stores. On here, you can see the outline of such a store. Into the store, we put our anchors, which are microwave transceivers, which has a fixed position within the store. Then, for smartphone store, we also have smartphones in the stores, of course. Those smartphones also get fitted with our microwave transceivers. So then we can send signals back and forth between them. With that, we can triangulate the position of the smartphones very accurately. You can imagine this somewhat like a combination of an RFID and GPS system. Okay, now we have the exact location of the phones at all times. What do we do with that? With that, we can divide our store into security zones and then trigger certain things such as alarms, but not just alarms. Basically, anything is possible here, depending on the position the phones are in. Now, one question remains, how do we put those microwave transceivers onto the phones in the best possible way? As you can see here, you'll also be able to later see our prototype for that. You put it in a small tag on the back of the phone and also develop the base station to go alongside it to put the phone in and also power it, charge it. And now you will see our video demonstration of how the system works.
Let's see if I can find a new smartphone here.
What's loud?
This looks nice. Where's the wire? Just work. I can actually try it out. I'm basically trying out the phone, saying it's a nice phone, and that it's nice that I can test it. I can actually see if it fits inside my pocket. And now I'm starting to wonder, did anyone notice that I put it in my pocket? Or did no one see? And because I think no one notices, I'm trying to steal it. And now the alarm sound should be playing.
Yes. Perfect. Now you see the security aspect of our system in use. But while this whole thing was going on, in the background we collected data on how often the phone got picked up and for how long it got used. This information our customers, the stores, can use to optimize their floor space according to their customer needs. Okay, now that you've seen our system, you're probably wondering, how can I buy this? You can buy this as a subscription. You'll pay around 30 euros per device per month. For that, you get access to our hardware and software, but we as a company will keep the access about the hardware and the software. This is necessary for us to make sure that the software is always up to date with the new security updates and that the hardware is serviced regularly. Only this way we can make sure that it's up to our security standards at all times. In addition to that, we are also currently developing a floor space optimizer AI we can sell to our customers for an additional fee to help them optimize their floor space further. Okay, now you know what we are planning on doing, and now Kai will tell you the next steps we need to do to actually make this a reality.
Thank you very much. So, as you saw, we have a working prototype at the moment, but this is nowhere near a finished product that we could sell. We estimate that we need about 100,000 euros to actually create a working product that we could sell and also produce the first batches. We would then focus on small specialized stores that specializes on smartphones, for example, O2 retail locations, where we also have some initial contacts. From that on, we want to expand to different retail chains, different countries, and also different product categories, since this concept is universal and not only applicable to smartphones. And this is our idea. We are TrackTech. We want to revolutionize the retail experience. And if any of you are interested in helping us by investing, or maybe you have some contacts into the retail industry, we would be very happy to get in touch with you. Thank you for your attention.
Thank you so much, TrackTech. Perfectly on time, even though with a little issue. Very well done. Okay, we start with the questions of the jury. You just raise your hand. I will use my phone to start the timer for that, so sorry for that. And let me know who wants to start. Yes.
How do you compare with the Apple Tech location service? No?
It's basically the same technology. We're actually using the transceiver from the same vendor that Apple uses for the AirTags. But the difference is that we have actually localized anchors, and Apple just uses the technology to get a distance measurement, for example, from your iPhone to the tag. And because we have multiple anchors installed in the store, we can actually triangulate your exact position and not just distance to, for example, the nearest iPhone. But the technology, the idea behind this is very similar.
Right, next one.
Yeah, thank you very much for this nice presentation. I also would love to hear from you, how do you compare to the standard theft protection systems which are available in the store, which are quite common for clothing and the like?
So I assume you mean those RFID tags you have on clothes, or?
Exactly, yeah, these 1-bit tags, yeah.
The difference is with those RFID tags, you can really triangulate the position of, or it's not done and couldn't be done to the same accuracy that we can with our technology. So you just, with these RFID tags, you basically just have like this barrier at the door and you see if someone passes it, and you can also block the signal very easily, which is much more difficult with our system. Yeah, this is basically the main advantage that we have over that. But it's also a lot more expensive.
Okay, thank you very much.
Wouldn't there be much more customer benefit if you can take the product at home than just taking it to the shop or so?
I don't quite understood your question. If you could repeat maybe? So what do you mean with take the product home?
Yeah, well, not just buying it, to test it at home.
That would be another business model. This business model more or less already exists, that you rent something, and if you like it, you can then buy it and you get the rent fees as a credit. This is, I think Groover is doing that, if I'm correctly informed. Yes, but this would be a completely other business model.
And my second question is, why do you think that your USP remains a USP over the time? Because technology seems to be, simple in that respect, such that Apple could, capture it.
You're right. There's always the possibility that another big player recognizes the technology and also comes and wants to compete in the market. This is why we decided on a subscription model. So we don't only want to sell you the technology, but we want to be your partner in business, and we want to take care of the complete system. So if there are any potential software bugs, if there are bugs in the hardware, security issues, we want to take care of that and basically have our USP that way and be a real business partner to you.
Thank you for that nice pitch. I would like to hear something about, you asked for 100,000 euro. What about the unit costs, the building up of the productions, and the advantage your customer has? How much is this advantage?
Very good question. The production cost, of course, it depends a lot on how many we actually produce. But for the technology, the main cost is the transceiver, which is about 15 euros at retail price. And then we also need, of course, additional electronics around it, PCB manufacturing, and then also the plastics. And we estimated that around between 50 and 60 euros for a reasonably sized batch. So if we say we can actually produce them in a few thousands and not just 100 of them. So this would make a return of investment at 2 months with our subscription-based model. But of course, this excludes salaries for technicians, maintenance fees, and stuff like that. And you had a second part to your question. I think I forgot it. Can you repeat it maybe?
What the price and the advantage for the customer? It's the business model. What is the price and the advantage for the customer compared to traditional models?
Compared to traditional models, yes, we are quite expensive. We have the subscription model. Normally you just buy those, for example, the wires that secure the phones to the table, which are not that cheap, but a lot cheaper than 30 euros per month per device. And the benefit is mainly that you have actually that you get more customers into your store, that the customers can actually try out the phones, and we would estimate that this also leads to fewer returns, more sold devices, compared than when you just have the devices at your shelf and the customer can just look at the data sheet. And also, of course, the biggest cost for a retail chain is floor space. And with all the data we gather, we want to optimize the floor space, which is also an additional advantage that's hard to put into any monetary numbers for us at the moment.
Have you talked to retail managers, and if yes, what was their reaction?
Yes, we talked, for example, to some O2 locations, and they were fairly excited about the idea because they said one of the main problems they have is that customers want to try out the devices. They can't, so they have to get them out from the back, or they have to give them their personal devices, and then it's also happened that they steal the personal devices from the employees. So they were quite excited about the idea, but they also had some concerns about security, which is why we developed some ideas with them together to use the position data, for example, to connect it to a revolving door that could automatically stop. But those ideas are not quite finished because there are a lot of regulatory things you have to think about when you design something like this.
All right, that's it. Thank you so much. A big applause to TrackTech. Okay, next up is Snext. Welcome on stage. Ooh, I see something showcased there. All right, quite a collection there. We're curious about that. Okay, same for you. I'll ask you if you're ready. You just give me a signal then. Yeah?
Yeah.
All right, then the 5 minutes start now.
I think it's safe to say we all like to snack. Some chips after a long, stressful day, or just something for in between. But if I open the bag, the possibility that it will be empty in a couple of minutes is very high. And how do I feel after I finish the whole bag at once? Well, not very good. I think we all know that chips aren't considered very health beneficial. And I'm not alone with this problem. 90% value healthy eating, but the current products on the market offer just low nutritional value. This is what Paul, Luca, and myself, as the founding teams of Snext, want to change. We want to combine snacking experience with healthy nutrition to create healthy snacks without compromise. Now, maybe you think that there are already plenty of healthy alternatives on the market, like these lentil chips, these vegetable chips, or even protein chips. But if you have a closer look, you see that the lentil chips still have a very high content of fat. The vegetable chips have a huge amount of sugar, and the protein chips are made, as most of the snacks, out of highly processed materials. In general, strong food processing leads to a decrease in fiber and micronutrients. But these ingredients don't just disappear, they accumulate in emerging side streams, which so far are unused in the food industry.
Yeah, and we use these side streams to enrich our products with valuable ingredients and simultaneously make our products more sustainable. To give you an example, when oil seeds are processed for oil production, you not only get the oil, but also a highly nutritious breast cake, which is still full of protein and fiber. The reason why these side streams are currently not used in food industry is because they negatively influence the texture, for example, the crispiness of our snack. By using food extrusion, we managed to establish an innovative texturizing process to solve this problem, to make these side streams usable. In the extruder, the raw material gets cooked by high temperature, high pressure, and high shear, created by 2 rotating screws. At the outlet, the material gets puffed, which creates the desired crisp of our product. In combination with the use of side streams, extrusion allows us to create snacks with great texture and high nutritional value. Speaking of nutritional value, we now want to show you our first product, the Sticks Oriental Ginger. Thanks to our process, our product, 100 grams of our product, contain the dry substance of 20 grams of fresh ginger and 25 grams of linseed. Due to these ingredients, our product outcompetes the average lentil chips significantly in all aspects. Our product contains 60% less fat because we don't fry the sticks and use extrusion instead, and therefore already also 25% less calories. Due to the side streams, our product contains 120% more fiber and 50% more protein. All this adds up to a Nutri-Score of A. And another big advantage of the side streams, we are 30% more sustainable than comparable chips.
Our secure side stream supply enables us to produce the sticks for 40 cents per unit, which is 50 grams. We will start selling our products on our online store, where we're charging a price of €1.99 per package. By cooperating with strategically selected influencers in combination with targeted advertisements on social media platforms, we're aiming to build a brand recognition and also to drive attention to our online store. And like this, we're expecting marketing costs of around €10,000 per month, resulting in an average of 10,000 monthly sold units in the first year. Right now, we are making final adjustments to our high-fidelity prototype, and we are finishing our website. Also, we are planning to launch our first product in 3 different flavors by the end of this year. Once we build our brand and also recognize some traction, we are planning to place cardboards in local supermarkets to utilize this additional sales channel as well. Thanks to our texturizing process of extrusion, we're seeing nearly unlimited potential in the incorporation of any other side stream there is. Due to its high versatility, we can quickly expand our product portfolio to all kinds of shapes and sizes, and we can also venture into different product categories such as cereals, for example, including...
And thank you. Last sentence.
Incorporating apple peel.
Thank you so much. Next. It already looks very delicious. Now it's time to snack. Very good. It's time to snack, and don't forget question. Okay. All right, who wants to start? While eating, or preferably not while eating. Please use the microphone so that the online audience understands your answer at least.
At the moment, we're having a raw material cost of around 34 cents per 100 grams. And there's a rule of thumb that you should add around 20% or up on that for the production, and to double down on that as a very conservative estimate for the total cost. Which would include the packaging, the storing, and yes. So we're operating at a gross profit margin before a marketing cost of 40 cents. What is it? 80%, right?
Mm. How easy is it to copy this? And do you have any protection? I mean, these CPGs are very powerful. They may say, "Oh, it tastes good. Let's do it."
So really, the challenge is to make it taste good. That was the hardest part, and before to get the texture. Normally, like peanut flips are made by extrusion, but you use not fiber-rich streams like the breast cake, but only starch or maize flour. And when you use these fibers, you can see that the ginger pomace is really fibrous. This makes it hard to get that crisp and to create that bubbles. So you have to find the perfect parameters, and it's not so easy to copy that.
How is it to get the raw materials? You know, it's side stream from food industry, so is it easy to get from them?
Yeah, I would say so. It's not very hard to get them. For example, here this ginger pommes, ginger press cake we got from a company, ginger juice company from Rastatt. And also this linseed press cake just from a oil mill in Germany. It's material that quite frequently is produced.
Do you need any approvals to get it sold? I mean, or can you just produce it and sell it? Approvals from food. I mean, this is food, and I mean, so you just cannot sell something, right?
Yeah, sure. The snacks we made, we can't just sell. We need standards and hygienic standards.
I have a question. It's an interesting product. I have a question. How do you, can you tell us something about your go-to-market? How do you want to start? One thing is to pay influencers. The other thing is, where do you want to start with the products? With the big companies, with the small ones, regional? How much do you know about the market?
Well, we want to start without the cooperation to a bigger company at the beginning. We want to more or less bootstrap it by ourselves in combination with the influencers and the social media advertisements. And I think for the market we have found some numbers and calculated coming from the total revenue of the snack market. Over the ratio of what from that revenue is coming from chips to how many units of chips must be sold with an average price of a chips package, which would be 200 million sold units in Germany per year. And as our target group, we identified the LOHAs. These are people that follow a lifestyle of health and sustainability, which would represent 15% of those purchases. And to have a number, what the goal would be in the following few years, so that I can give you a number, would be to cover 5% of that market, which would equal 1.5 million units in this in the year. Did that answer your question?
I wanted to know how much you know about the market and how experienced you are in the market, or whether you look for someone with experience in the food market.
Our main experience comes from the consumption of said chips at the moment.
So, no, I have to cut you off here. Thank you so much. That was a perfect answer, I think. Thank you. Okay, so now I have to look at my little... Yes, third up is Sign Me Up. I welcome you on stage. And thank you again to Snaxt. You can also take both microphones if you want to. Okay. Yes. All right, again, a question to you. Are you ready? Then you can start.
Okay, big thanks to Ramona. Now we have a test for you. Hands up who just paid attention. Okay, that looks promising. Now keep your hands up if you understood her message. Not so promising. Let's take a look at the communication barrier you just experienced. Ramona is deaf and communicates via German. You are all hearing persons using spoken language. Let's say Hannes tries to talk to Ramona. Now there are multiple solutions on how she can understand him. The easiest one might be a voice-to-text translation. Now she answers using German Sign Language. What's the solution here? Well, they need to hire a sign language interpreter. Those come with two main issues. They cost a lot of money and you need to book them at least 4 weeks in advance. Right there, Sign Me Up comes into place. Our mission is to break the communication barrier between the deaf and hearing community. Niels will explain you how.
So to tackle this communication barrier, we are developing an app that enables real-time communication between a deaf and a hearing speaker. Our market competitors are sign language interpreters. So what makes our solution stand out? First, we are way more affordable, since we will charge significantly less than 85 euros per hour. Secondly, our app can be used spontaneously, whereas you have to book an interpreter 4 weeks in advance. Next, our app is accessible almost everywhere. You could even use it to communicate with your hairdresser, whereas your health insurance would never provide you with an interpreter for that. So, how do we translate sign language to text? At first, you have to point your phone's camera at the upper body of the person speaking sign language. In the next step, the features relevant for sign language interpretation have to be extracted. These are fingers, arms, and certain facial features. As a result, you see some kind of moving skeleton matching the movements of the speaker. Now, the performed gestures have to be recognized. All our computer vision model needs to do so are the extracted features. This ensures lower data sizes compared to using the whole video and enables our translation to work in real time. In the last step, a row of gestures has to be translated to a full sentence. This is necessary because sign language follows different grammatical rules than spoken language. Therefore, we plan to train an AI model which performs the grammatical rectification and contextualization of gestures. We already have a first prototype, which was tested by our dev partners. Based on a random forest classifier, it is able to translate 50 gestures in real time. During these tests, we got valuable feedback and gained insights on the next developmental steps to improve our prototype. But for now, we would like you to have a look at the performance of our prototype yourselves.
We want our app to have a big social impact. So our long-term goal is a DIGA certification. Then all app costs would be covered by health insurances, making the app completely free for all users. Until then, we might need some bridge financing. This would be a B2C subscription model. Monthly prices would range from 5 to 50 euros depending on the app usage. The impact would come for 140,000 Germans who need to communicate via sign language. Let's estimate they need 10 hearing contracts in various everyday situations. Those 10 need our app since the gestures are translated towards them. Apply some simple math and we end up with 1.4 million potential app users. And now back to us. We have a first prototype and gained some early success with a second place at the KIT Sustainable Innovation Challenge. The next development steps would be voice-to-text implementation and dynamic gesture recognition. By March 2024, we would have a prototype which would be able to translate around 300 gestures and would have 50 beta users. We want to accomplish that together with our dev partners, which we developed connections with in the last several months. Our team would be nothing without Hannes and Salman. They'll be happy to answer all your technical questions. Come to our booth later on, try out our prototype, discuss our project, and let us together break the communication barrier between deaf and hearing people.
Very well done. Perfectly on time. And yeah, we have the first question already.
Yeah, thanks a lot. It's a great idea, I think. Now, one of the problems in these things is how do you overcome the cold start? How do you train your algorithms? How do you have access to enough data to really come to a model that works?
Okay, thanks for a great question. We of course thought of that. I think that comes with two parts. One I can explain, these are the partners we have within the dev community, and Also on the technical side, we have an idea on how to challenge this. We need a lot of data thing.
So at start, for now, we have a model that only recognizes 50 gestures, and we use a classifier called random forest classifier to do this model, and it is a really fast classifier. The main idea is to divide our models in for different persons, because each person have like their styling, their signing styles, and from each person we want to divide also different use cases. For example, a use case for doctor appointment, use case for also team meetings, for job interviews, and also a use case for alphabet, so that we get the higher possible accuracy. Yeah. I hope that answered the question.
All right.
So you said you need cloud, you need subscription model in the beginning. If you're using random forest, which is not computationally really intense, and also potentially using pose estimation, wouldn't you do that directly on your mobile device, or do you want to have, or do you go for cloud processing?
Okay, for that we are not entirely decided because we are not bound to the random forest classifier after all. But in our current prototype will work on device because the gesture recognition, state-of-the-art gesture recognition with libraries, there's OpenCV, there's MediaPipe by Google, who are specified for mobile devices. In the end, if every user has his or her own model, I think it would be, or we think it would be rather promising to store these in cloud to make it available on multiple devices, for example, or generate an even stronger generalized model from that.
Maybe as a technical question, have you considered to do something like transfer learning? I mean, you could have basically one base model and then just retrain on the spot. I mean, that would be a very promising approach, I think.
Yeah, that I think somehow connects to this idea of dividing the big problem into small problems.
Yes. Okay. So please come with me here. For example, one specific gesture. Let's say food is up here in this room. For every person, the gesture is somewhere located up here. So we can, from every single personalized model, from every data point we get from our users, we can approximate this general region. For every person, there is a slight adjustment we need to make. So yes, transfer learning is definitely a possibility and inherent to our approach.
Could you tell me something about the competition? And I would be interested whether this could be rolled out international. Is the gesture similar or the same in all countries or cultures, or is that very different? So can you go international without big barriers, or is there an adoption for every country?
Yeah, maybe Niels can answer.
So the last answer is very short. Yes, it's different. Even Austria has a different sign language. It's not like there is a like a spoken language that we use almost the same language. They are very different, and also there's dialects, which is also why this individualization of the models is so important. And our competitors are mostly sign language interpreters at first, either in person or remote. In person, they are way more expensive and do need this like long waiting time. And a remote translator, you don't have to wait that long. However, they are still very expensive. And another problem is that you need very good internet translation. Otherwise, also the translation quality will suffer. For us, we are way more affordable, perfectly accessible. However, our translation quality will be lower. It will probably more like sufficient to say what you want, what you need, but you won't really start like philosophical conversations.
All right, big applause to sign me up for this. Okay, next up is Sky Squadron. Oh, what a name. I'm sure you can pronounce it better, I'm sorry. Looking forward to your pitch, and yeah, let me know when you're ready. Ready?
We're ready.
Okay, then your 5 minutes start now.
So, good evening, everybody. Thank you for coming. I wanted to start this by talking about the future, what's ahead of us and whatnot. But really, the future already came. We don't need to talk about it. We need to talk about now. By the end of 2022, Germany already had over 28,000 wind turbines. Not only that, we've already observed a constant growth of wind energy production over the last years. This trend will keep developing as we transition further into renewables. Since we are relying so much more on these systems, it is imperative that we make sure they are functioning properly. In a context where there are massive wind parks, even bigger wind turbines, and less spare parts than ever, we need to make inspections more relevant. The knowledge of the dynamic behavior of wind turbines while they are functioning is highly important to us. Otherwise, the risk of having catastrophic failures increases drastically. Dynamic measurements can help us analyze and optimize the behavior and the performance of the turbines while making sure they're functioning properly. For this reason, we need to analyze, for example, the vibration of the blades, the eccentricities or deformations in the system. This is more relevant now than ever. What is the problem in all of this, you may ask yourselves? Well, current measuring methods are reaching the limits of their capabilities. Internal sensors are less accurate, they have limited frequency ranges, and they have a high danger of being damaged by environmental hazards. There are also external measuring methods which involve putting tools around the turbines. This can compensate for the problems, but they involve too many people. They have slow setups, and they are all in all long, tedious, and time-consuming tasks. Realistically, they can't be efficiently applied in wind parks where you have tens up to hundreds of turbines without it costing too much money to the customer. Here is where our solution comes in.
Our solution consists of a highly mobile photogrammetry system, which is able to perform fast dynamic measurements on a wind turbine without complex setup. Furthermore, we're able to measure every point on a wind turbine. So how is the system working? Our system consists of one controller who starts the drones and to look at the system, and two to three drones, each carrying a high-resolution camera. The drones position themselves in front of the camera, in front of the wind turbine, and doing video shots. Doing video shots. Together with these video shots and the usage of a photogrammetry method, we are able to detect the dynamic movement of a wind turbine. These measurements we can store, and later we analyze the vibrations. But enough about the theory, let's talk about the real system. On the left, you can see the movements of our drones positioning themselves in front of the wind turbine. And on the right side, you see the video capture and the corresponding measurements. As you can see, we are able to detect the dynamic measurements of the wind turbines, and so we can make assumptions about the structural damage of the wind turbines.
I think it's enough to know about the technical and the problems what is happening in the wind turbine. Now comes to our services and the financial plan. For our services, we send our team of the wind turbines to the wind farm, which is contacted by us to the by the wind owners. Then we take the dynamic measurements. After taking the dynamic measurement, we analyze the data, and after analyzing the data, we send this data to the wind turbine owner, which give us some service charges in our services. So now it's an important question, how we will grow in the next years. So in next 5 to 6 years, you can see that we're having a growing graph, and in the start of 2026, we will reach our break-even point. But for reaching this break-even point, there are some hurdles. We call these hurdles a competition, and we have a healthy competition in that field, and biggest one is a Deutsche Windtechnik, which is not only a service provider for the operations and the maintenance, but also a wind turbine owner. But to compete with them in the field of market, we have to launch ourselves in the market. So we need a solid roadmap. Now you can see here, we are searching for the investors and the sponsors who would sponsor us in that field. And we launch ourselves with these 3 engineers who are studying in KIT, in the ETIT, and from different continent. Thank you for your listening. If you have some questions, you can contact us on these media sites. Thank you.
Perfectly on time. And we jump right into the questions.
Okay. So I think in each of the large wind turbines we have at the moment, we have vibration sensors, because you need to check whether there is ice on the surface, no? And with this vibration, you can also measure the stability of the structure. No? So this would be a competing, let's say, system. Are you aware of that? No?
I didn't catch the question. Can you please repeat it?
At least it. You have oscillation measuring systems already installed in these systems, because you need to measure whether there is ice on the surface. No? Yeah, in order to protect people around, that if the ice is going like a bomb, you know, and so this is already installed, you know, and so with that you can also measure structural changes. So.
Yes, basically that's the slide you can see here. Here we have internal sensors sensoring the movements of the blade. So we have different problems here. The main problem is environmental hazards. So basically, if a thunder struck the wind turbine, it basically comes to a catastrophic failure of the system. And so they bring on these sensors more on the middle of the wind turbine, and not on the tip of the wind turbine where the vibrations are most interesting. So here we have the advantage that our system is not constrained by the environmental hazards. We can bring up our markers at any position, and also at the outer position of the wind turbine, we have more vibrations and the more interesting vibrations. So all in all, we are aware of this problem, but we think we have more advantages than this system at the moment.
Well, how is the inspection done today? Or is it done today using these kind of sensors, or even?
Basically, yes. If we talk about inspection, there's a huge area, because there are different kind of inspections, checking for structural damages, etc. We are talking about the dynamic measurements, and the dynamic measurements were at the moment taken by the sensors and the external measurements, this one here. Basically, you can go up there, check for lasers, or bring lasers on the site and build up the system. It's a huge effort. You need a lot of personal equipment and so on. So basically, our system is more mobile, and so on. We need less time for the inspection.
Any further questions?
Just one more technical question. Have you ever tried photogrammetry from a flying drone?
Yes.
Is it working? Do you have a technical demonstration with you?
Yes, we did it in 2 ways. One in the real world, which is not shown here because it doesn't look very good on the pitch. It's possible to do it. The problems are the vibrations. And the system we developed here, I have a backup slide that's easier to understand here. Sorry. So basically the system we developed here is have 4 steps. The first step is the filtering step. That's not important now here, but the second step is the important step. Here we do a so-called calibration. So we find out by looking at a pattern at the base of the wind turbine, we can find out the position of the drones. So basically, if the drones are, for example, swinging through the air, it basically captured one moment. We calibrate our camera, find out where the camera system is,
And in the next step, we do the photogrammetry part, which is basically shown here. It's a little bit complicated to show it all. You can come after the session to us. But basically, yes, we tried it in simulation and in real world, and we are certain that will work. At the moment, we are calculating with the accuracy less than centimeters. So we achieved centimeters. It could be even more if we have more resolution in our cameras.
One last question.
Is there a difference between offshore and normal windmills? So is this system possible to measure in any kind of environment?
Basically, yes.
Yeah, exactly. That was part of the inspiration for this. As you see, if we take dynamic measurements using external methods, we have to install cameras or lasers or whatnot around the turbine. Doing this in offshore turbines involves bringing boats or big ships. In this way, we can actually spare a lot of money to customers by just bringing one small boat with the set of drones and the technician.
All right, thank you so much. Now, next up is Gecko. We're looking forward to hear what this little animal is all about. And they even got matching t-shirts, I love it. Welcome on stage. Oh, I'm so sorry. Sign Me Up did as well. Okay, again, you just let me know when you're ready. You're ready? Okay, then the 5 minutes start now.
Meet Justice, a hard-working student facing the challenge of skyrocketing energy bills. Could turning off the heater help him save money? But then he shivers in the cold. Taking freezing cold showers? Absolutely not. Justice knows there must be another solution. And there is. Introducing Gecko, a personalized smart energy management device.
Thank you. Merry Christmas, you too.
Gecko becomes Justice's own digital energy consultant. By installing Gecko on his wall, Justice gains real-time access to temperature, humidity, and CO2 readings through his app. Now, with the power of Gecko, Justice receives personalized advice. Additionally, he can connect with friends and stay motivated during his energy-saving journey. The next time Justice receives his energy bill, he's in for a pleasant surprise. He realizes just how much Gecko has paid off as he starts receiving money back for saving energy. Gecko, take control, save money, and make a positive impact on the environment today.
So, hello and welcome. Thank you so much for watching the video. I hope you got the idea about the Gecko. So, we have main three components: application, personalized thermal model, and our Gecko, which is equipped with the temperature, humidity, and CO2 sensor. Idea is very simple. We gather the data through the model, through the sensors, and we feed the data to the model, and then we get the personalized and customized suggestion on how to save energy. So basically, we are using the machine learning to create the personalized thermal model of your own room. That's how Gecko becomes your digital energy consultant. You can see over here, we have smart control system, Wiesmann and Tado, which is highly analytical, but comes with a very high price range. There are additional thermometers available on the market, but they are not that highly accurate. Where Gecko is highly accurate as well as provide the additional information. That's how Gecko comes one step before the smart control system, where Gecko becomes your digital consultant.
Now let's zoom out and take a look at the whole market. So over the last few years, we've observed an increase of 24% market size for smart energy management systems. And looking ahead to 2027, it is estimated that the penetration rate will reach 63%, meaning that 1/3 of German households will use smart energy management by then. So the potential is huge and the market is growing. And to ensure sustainable growth, we've developed a diversified revenue model. So for those who just want to dip their toes into energy management, our basic version is engineered to deliver temperature and humidity data. And for those who seek more comprehensive insights, our premium version offers additional CO2 data, better prediction, and more refined design, like the gecko you see here. And both versions offer the advanced app in the first 6 months. So our advanced app has advanced analytics, gamification, and networking capabilities, and users can subscribe to this app for a rate of 48 euros per year. For those who don't want to pay, we also have a free app which offers live data and basic functionality, empowering everyone to be part in this energy-saving journey. Now let's look at the numbers. So in the first year, we project modest revenue as we focus on product development. However, after 3 years, we estimate a total revenue of more than 1 million euros with a estimated sales forecast of over 13,000 units.
We have formed a team of industrial and electrical engineers with a wide variety of skills and are therefore confident to bring our idea to life. Also, with the current situation in the energy markets, now is the perfect time to build this company. Until now, we have brought our idea from a rough sketch to a working prototype, which simultaneously serves as a proof of concept for our technology. Our next steps will be the refining of our product, which will enable us to launch our Gecko online and in selected stores end of 2024. But this is only the start of it. Since our main expertise lies in our analytics power, we're planning to connect also to other existing devices and are hoping to extend our business model to a B2B case where we provide complete software solutions. That said, we're looking for a business angel that help bring our Gecko to the market soon. Thank you.
Nice. Thank you. Very well done. Questions? Yeah. Ooh.
Okay. Okay, good. So the question is, do you want to develop your own hardware, or would you like to use existing systems? No?
We already developed our own hardware, which is installed in the Gecko, which comprise the two sensors, which is mainly CO2 sensor and humidity and temperature. But to expand our business in the later, we would like to integrate our system with the others also. But in the base model, we are providing our own hardware also.
Okay.
What is the difference between open source, let's say, models or software available, for example, in smart home direction, like Home Assistant? They also have a lot of energy saving plugins. What is the difference, and why should somebody buy additionally this consultant rather than using community-based application software plugin for Home Assistant?
First of all, a big difference is in the price. We are aware that there are a lot of solutions. Seen any solution at Friends or anywhere. We did also market research that there is still the room, and we think that our difference really is that we don't sell actuators or something, and we really try to model your home temperature and humidity wise, and then give you perfect recommendations what you can do. And then we also have a function to be implemented, which is test the control system, and then you can test actually whether such systems ever break even.
Also a technical question. Can you explain me how you can train a thermal model by only using the temperature in the room? So how do you gather the information about thermal losses and so on?
So what we have to as data is the inside temperature and the outside temperature from weather APIs. And so we had two approaches. One physical approach based on RNC components that did not work as well as the AI-based approach, which consists of an LSTM network. There we gained a mean squared error of 0.28, which is just a few cents. And also, of course, you have a dip when you open the window, or if maybe you cook something, then it probably gets warmer. But as we need always a time interval where we predict, for example, how much money you can save or spend with that heater settings. And if the dips cancel out each other, we still have a good correction. So we have to hit the average, not every single point, and which makes it easier. And that's also a reason why we plan to that everything is developed by end of 2024, and because we need 1 year of gathering data, and we started in about April, and to see how the model behaves in every cycle of the year or period of the year.
Partly answered. Thank you for the for your presentation. I was also wondering whether this would work without the user's interference, because you also have dynamic processes going on. So you have to encourage the home user to close the valve of the radiator, open the valve of the radiator, and do some sort of excitation of the entire process. Without that, I was wondering, how do you get the information to train your networks?
We also, when testing a method or something, it always says that for one night you should not turn on your heater at least. But also over the time, as we said, with the small dips, that we hope that the model itself learns this. And also what we plan is by the end of next year that we have some interfaces to existing systems, and then we get such information from those systems if the user have installed them.
One last question, if there's any. Oh yeah.
So most apartments are not a single room apartment. So are you looking at having several geckos in an apartment?
You could also place several geckos in the apartment, but also what we've seen so far is that it needs just a few days of data gathering in one room to have a precise model for the next few weeks even, because the temperature of the days is not completely independent. If it was warm yesterday, it's likely to be warm tomorrow as well. And so you can place the gecko in different rooms and build a model in different rooms. However, of course, if it changes from winter to summer, you probably would have to put it more often in the different rooms if you just have one.
All right, big applause to Gecko. Thank you so much. Last but not least, we have Disoltic. Welcome on stage. Okay, here again the question. Let me know when you're ready.
Yes.
Okay, then your time starts now.
Hello everyone. As the last team today, I want to start with a question. What would you say ChatGPT, a satellite, and your notebook have in common? They all work only because of their microchips. You just have to look around, chips are everywhere, and we are more dependent than ever. What do you think? How many chips are in the world? Maybe 1 billion? These are just our notebooks. Every year, 1 trillion chips are produced. That's 30,000 chips per second. We have to rethink this because the huge consumption is combined with many environmental impacts. Apple, for example, generates 1/3 of its total emissions just from the production of integrated circuits. But it doesn't have to be that way. Think back to your notebook. The average usage time of notebooks is 5 years. However, the individual chips can be operated for up to 15 years. What does it look like to you? For us, this looks like unused potential. And the crazy thing is, it is similar for most other electronic devices. We see the current linear system of the electronics industry is neither ecological due to the high emissions, nor economical due to the unused potential.
So for us, it's absolutely clear we need to rethink the electronic industry and change it to a circular economy. And this means we need to extract the used chips carefully from the printed circuit boards. But how can we do it? We could easily desolder it by hand, but this is not a solution because we can't control the process. So we need to do it better. So we as Desoldic have developed a fast, reliable and automated desoldering line to close this cycle. And now, let's say hello to our first prototype. And now, let's dive into our technology. First, we place the PCBs in our carrier system. Then, we localize the chips. And if we have the exact position, we can use our multidimensional and selective heating process to follow the temperature profile. And this ensures that our chips are stressed as little as possible. Then, we can use our pick-and-place robot to extract the chip. So now we have our resolved components, but they still need to be cleaned, rebuilt, and tested. But these 3 steps are not part of our solution because other companies already tried this.
Nice prototype, but how are we going to make money? We will operate as a B2B desoldering service provider. That means we receive the printed circuit board from our customers and return the desoldered chips. We identify different markets, but in the beginning, we will start targeting the high reliability sector, such as aerospace and automotive industries, because this sector already reuses more than 9 million components each year. In order to process high volumes of electronic components, our goal is to desolder nearly 500,000 chips each year with just one desoldering line. The desoldering costs are roughly 70 cents per chip, and with a desoldering price of 10 euros per chip, we expect to break even in a little more than 4 years. Currently, desoldering is either done by hand or with semi-automatic machines, but those techniques are not applicable because either the temperature cannot be controlled or the throughput is not high enough. Therefore, the introduction of our desoldering device, focusing on high reliability and high throughput, is unique and currently not available on the market.
A high goal we can only achieve with our wonderful team. We are all ambitious electrical engineers and established several contacts in the electronic industry. Now let's have a look at our roadmap. At a midterm pitch, we announced that we want to develop a desoldering line. And today we showed you a fully functional prototype in just 4 months. In addition to our development, we attended fairs and found out that the demand for component reclaim has increased constantly. And here we are today. But now let's talk to business. Further research will be necessary in the next 2 years where we can optimize our existing prototype. A big milestone for us is the market entry in 2026 to bring our vision to reality. We want a circular economy that is both economical and ecological. We are rethinking the electronic industry. We are Desoldic.
Nice. A very well presentation. Last but not least. All right, questions? Yes.
Do you have a calculation? Because, I mean, it's a big machine and
Yeah.
probably lots of software investments and all that. Calculation.
Yeah. So our current prototype is sadly not capable for the complete production of 500,000 chips per year due to the SIL, but we estimated that the fully functional machine would cost 400,000 euros just for material costs. So that's the price. But if you would operate it at fully desoldering capabilities, you would break even in a little more than 1.5 months.
Next question. Yeah.
I'm struggling a little bit. You know, there is a risk that, of course, damage the chip. I mean, ESD or something like that. And I'm just wondering. I mean, you have a lot of different chips, and it's very complex to test them. And I'm wondering who is ensuring that they are really 100% functional afterwards.
So generally, the JEDEC norm says that you can desolder or resolder a chip 3 times. So there's already not only 1 cycle, but there are already 3. And we also found papers that stated that there are even more times possible, up to 10. Looking at the testing questions, there are already machines out there where you can put the chip inside, and then you press them down, and then all the pins are attached, and then you can run a testing program. But that will not our service, because there are already companies that are doing that.
Sorry, can I add something? It's really important to say that why the chip is not damaged is because of our control. So if we have, like, can you go to our control curve? Andere Richtung. Sorry. If you go to our control curve, you can see that it's really important that you follow like discrete and temperature difference. So like if you speed up the process too fast, your chip will crack. And if you do it in a really good, like in a controlled way, you can verify that your chip is not damaged by your system itself. So that's why you don't need to test anymore. Like our biggest competitor don't use tests. They just use it when you order it. So that's why you don't need it.
I had a question about the supply chain. I mean, how is that organized? You need a big stream of input, don't you? Where do you get that from?
So from direct contracts to the manufacturers, or also to the electronic manufacturers who are selling it. So that would be very important that the supply is. Yeah, that's all something, and that's yeah. Yeah. So Max, yeah.
Yes. Just one sentence to this. There is a refurbish company near Karlsruhe that is refurbishing electronic devices, and maybe this will be your partners. These companies will be your partners for the future. My question would be, I think it's a really important topic concerning sustainability. And there will be a market. Why do you wait until 2026 with the market entry? This is a bit dangerous, I think.
So for us, it's very important to be able to really precisely follow that curve, as Ken said before. So we have to develop the machine that's really capable of doing that. And that will take a little bit of time, effort, money, and that's why we thought, okay, 2026 could be possible. Because it's not so easy. It's quite a complicated process, yeah.
Yeah, thank you very much for this important topic. So think of you're successful with your technology, and everyone wants to buy it and have your service. What's about the market ramp up? Can you say something about that?
Yeah. So the process is very much scalable. So if the demand for desoldering is increasing. If you have one line, building another line could be totally possible. And if the demand increases even more, we are also open about selling the machine to other suppliers, so that they can do it themselves, and we are just a provider of the machine.
All right, with that being said, thank you so much, Disoltec. Yeah, and a big applause again to all 6 of our teams. I think they deserve that. Now breathe a bit, relax a bit, while we have the honor to listen to 2 other topics, right? First up is Thijs.
Thanks. So thanks for having me. Great to be back at Zeal 2023. Thanks Jürgen for hosting us. Great location, great. Good job to all the pitches to the teams. Now I stand as a Lückenbüßer, so to say, to bridge the time, I guess, between the jury decision and your pitches. So I'll keep it short. My name is Max Riedel. I'm heading the Zeiss Innovation Hub at KIT. This is this building you see here on the photo. It's actually located at the North Campus of KIT. Some of you might have seen it because, well, no, you were not part of the last year, obviously, where we had these pitches here at the Innovation Hub. Anyways, what do? That's what we try to do. We try to turn today's research into tomorrow's applications together with partners. I can talk a long time about what this means. Basically, we are trying we're at the KIT, we're looking around us, what's the research all around us, how does this relate to Zeiss current business and potential Zeiss future business, and we really look far into the future, 10, even 20 years. And we do this because it's in our genes. Actually, university-industry collaboration is kind of how the company got founded. So Carl Zeiss was an entrepreneur running a workshop on loops and microscopes, and they were never really up to the standards until he met Ernst Abbe. All the physicists know him. He's basically developed one of the fundamental laws of optics, how an optical system, what's the resolution of an optical system. And when he introduced basically physics and combined this with the workshop technology, that made kind of the breakthrough for the company. So that's what we've been doing for 175 years, bringing together university and industry. That's what we still today. So pretty proud that we received the Zukunftspreis, which is the prize of the German president for innovation in technology companies 2 times in a row now. The latest light sheet is a microscopy technique. That's basically based on a Nobel Prize from 2014. We worked very closely with the Nobel Prize winner to bring this to the market. EUV is extreme ultraviolet lithography, and that took also around 20 years to bring to the market from the first ideas, and many companies, including Trumpf and also Fraunhofer, to bring this to the market. So 2 examples where they are now on the market, and our hub is trying to basically lay the foundations for something like this, maybe in 10 years, maybe in 20 years. Very big, ambitious, but it's very fun to work on this. 2 more words about Zeiss, the back of the mother company, so to say. Many of you might know Zeiss for this segment here, consumer optics. So this is where you have glasses, lens glasses, where you have binoculars, things like that. As you can see, it's actually the smallest part of Zeiss. We have a medical technology department, which is also a topic where we are working on medical robotics, actually medical surgery robotics of the future. We have quality control in industrial setting and tools for researchers. This is also where the microscopy is in. And we have by now the biggest department, semiconductor, which is producing lithography optics for semiconductor, basically. I skipped this one. I just tell you the 3 topics we are working on at the North Campus. Medical robotics are already mentioned. So we are trying to automize and autonomize the eye surgery of the future, let's say. Second one is integrated photonics, obviously an important topic for a photonics company like we are. And the third one has a little bit cryptic optical analytics solutions for sustainable industry. This is about optical solutions for circular economy, what we just heard about, for recycling, for remanufacturing, things like that. And we work a lot with partners. As you see, some of our partners here, KIT is obviously everywhere, but also a lot of other institutes and also companies. And we have a great team, and obviously we're looking for good people to join this team as students, we have up to these 20 core team members. We typically have 20 to 30 students. And we always have open positions. Just have a look here on our webpage. You can subscribe to our newsletter. It's at the bottom of the page. And you get infos about events we're doing, job ads, and so on. And yeah, we'd be happy to see some of you at the hub and at SAIS in general. Thanks.
Thank you. Okay, it was really cool to be at SAIS Innovation Hub last year. It's really cool to be here. And yeah, let's see where we end up next year. Next up is Aka with a presentation, and it's just being set up. Looks okay-ish for now. Yes, that's working. Okay.
Thank you for the wonderful event. Very nice presentation from all the 6 teams, and I congratulate you starting from an idea, coming to a final presentation, and also wishing you all the best for all the 6 teams. So I'm Harsha Vishnukumar, Head of Product Innovation at Akkodis. So Akkodis is a company which is formulated by merger of Modis and Akka together. And we have around 50,000 employees worldwide in almost have 30 plus years of experience, and also 4 billion euro digital engineering and R&D services revenue worldwide. We also do 4 different lines. So one is talent and the academy, solution and consulting. So we are into engineering services and IT services, but also one that I would like to deep dive here is the Germany side, where we have over 6,000 engineers, employees, and over 700 million euro revenue. And we also play globally. We have engineering services from Germany offered to worldwide customers. And we are also developing multiple products that I will zoom in now, which is our product line. We have multiple product lines. ProofTech, which is in the market since 25 years. We also have products which are AI core, UI tested, and so on. These are the products which are model-based AI solutions. And we also support all the customers. So starting from a coffee machine company to an autonomous driving, from instrument cluster or HMI devices to any kind of complex systems, we're able to use our software products, and help them validate and test them. We also have automation, so we help our customers to automate and also make sure that all our data is at the end, safe and secure, and most of our products are running locally, but we also offer cloud solutions. What I would like to also deep dive the next level is some of the interesting projects and interesting products that we have. One of the products that I would like to mention is AI Core, which I am heading at the moment, and where we also extract really interesting information from the road, from the streets, or also from any kind of automation. For example, here we can use our software to understand classical mechatronics devices and get the feedback so that we don't need to invest in expensive Industry 4.4 devices. Rather than using a classical device, we can use our software and tool to get all the information digitally and then use it and connect the devices or tools to other tools or maybe even cloud. Here you can see some examples about object detection. We have some examples about traffic sign, traffic light detection, where we can help our customers to validate their systems, ADAS advanced driver systems. And also we are going one level up and also understanding the scenarios like overtaking scenarios or emergency braking scenarios and so on. This is a deep dive into what we are doing. We are a cool team of engineers who are developing products. We are making a vision. We are trying to develop the products for now and then which can be used in the future. and also the products are getting maintained and managed within our team. I would say this would be a short introduction. Hope I'm on time. And of course, we are looking for multiple students and research colleagues within our team, because we are developing products and also engineering services. We would be very happy to have you on the team. And of course, we will support as far as possible from our side. Thank you so much.
Thanks again to all the company presentations, and again for sponsoring this amazing event, or the whole journey of the students, the Student Innovation Lab. All right, now it's getting interesting. You can maybe? Oh yes, now. The jury is now allowed to leave the room, go outside and discuss the two main topics, best product and best pitch. Best presentation. We're very much looking forward to hear about that. And all the audience in the room and also online, please vote for the darling of the day. So every vote counts. Scan the QR code, use your mobile devices. And yeah, let's see who's made the best impression on you. With that being said, my job here is over, and I hand over to my colleague Clara.
So hello from my side, I'm Clara from the SIL organization team. And after the great pitches of today, we're happy to have the winning team from last year's SIL round here, Badcam. And Robin, yes. Robin will now introduce Badcam to you and show what's possible after SIL.
Hello. Can you hear me? Yes. Perfect. Yeah. So I'm Robin from Badcam. Maybe some of you will remember us from the last round of SIL. And unfortunately, I'm the only one. Okay. Unfortunately, I'm the only one from my team having time today. So I thought I brought a picture of the rest of the team: Jan, Philipp, Antonius, and Michi. And during the last SIL round, we developed the idea of smart glasses for blind people to detect obstacles above the blind cane. So obstacles the blind people cannot detect alone with the blind cane. And for that, we use cameras with which we can detect obstacles, and then we use haptic vibrational feedback on the sides of the glasses to warn the blind people about obstacles so that they can avoid them early and properly. And today I want to talk about a bit about our journey after SIL, the challenges we faced, and also want to focus on three key lessons we learned during the recent months. And I want to start with a slide from one of the first SIL seminars from Sarah and Christine. Maybe some of the SIL participants may remember it. And I remember that they told us that the experience during SIL is a bit like the life of a real entrepreneur. That it's like a big roller coaster ride with many ups and downs, with many exciting moments, but also many doubts and many uncertainties. And that pretty much sums up the way we also felt during and also after SIL as a team. And the slide also highlights that SIL is a protected environment to gather experience. So you have submissions and tasks, you get credit points, and in a positive way, SIL pushes you as a team forward to have progress in your project. And that's what's not certainly the case anymore after SIL. And that's what we as a team also struggled with. that you have to study for exams, you have to take courses, you have to finish your studies while also trying to found a startup. And so for the first couple of weeks, it was really hard for us to set and achieve our goals, and also just to have time to work on the project again. And that's why we decided to apply for additional pitch competitions and accelerator programs. And that's what led us to also have again those obligatory workshops to talk to other founders which are in the same situation as we are, and that pretty much not only boosted our project and helped us to get funding for continuing working on our prototypes, but also helped to boost the motivation again in our teams. So that's really an advice I can have for the other teams if you decide to continue working on your project, that it helps to maybe apply for any accelerators. And what I didn't know at the time when we were finished with SIL, that there are so many accelerators in Baden-Württemberg alone for virtually any field of technology. So regardless whether you're in the life science field or in the energy field, there are so many opportunities to connect with people who are in the same situation as you are, and also to gather more experience and insights into your topics. And also the KIT has so many possibilities, like pitch competitions from the Pioniergarage and the Gründerschmiede. So that's really what I can recommend to the other teams. If you maybe are in a similar situation in a couple of weeks as we were, that's a really good hint to keep on going with the project. And the next point is that during SIL, we actually developed our first functioning prototype, which you can see on the top left there. But you can also see that it's not the most fashionable looking design. And there was a point that we just had to accept as a team that as electrical engineers, it's pretty hard to develop a good looking, fashionable prototype. So we asked one of our friends, Antonius, who is not just a great guy, but also a pretty good mechanical engineer, if he wants to join with us. And within a couple of weeks, he developed a second prototype over here, which I would say is pretty good looking and fashionable. And that's another advice I have for the other teams, that it's quite easy to find other members for your team if you need them during your studies, because you know so many people, you have so many friends who study in different fields. So maybe you can ask yourself as a team if you need more members, and use the chances now during your studies to find them, because that's what also other startup founders told us at the events, that it's quite hard after studying to find people who fit into the team, who are also committed, and to have the skills needed for the project. And the last thing I want to talk about is that, especially at the pitching competitions, we realized how much SIL helped us, because you get a deep understanding about the technical and the business aspects, and you also know how to convince your audience. And I think that's a really important point when founding a startup, and that's also what I've seen here at the pitches, that every one of you guys had such a great pitches, and that's important because eventually you need to convince investors to get funding. You need to find supporters on social media or on other channels, and also you need to convince your customer to buy the product eventually. So that's a really important step. But what is also important, that you not just know how to sell the product, but to sell the right product. And that's what we also try to do in the last couple of months. That's why we decided to go to the Site City, which is one of the biggest fairs for aiding devices for the blind in the world, and tested again our prototypes with them to make sure that we develop really something they need. And I think that's also a really important point, that validation doesn't end after SIL, and it's always a question you should ask yourself if you develop the right product, because no market need is by far the main reason for startups to fail. So I think that's an important point. And yeah, we continue on our journey and try to develop a
product within 2 or 3 years, and I was so excited to see the pictures and hope most of you teams continue your startup journey after SIL. Thanks you. Thanks for the attention.
Thank you, Robin. And so before the results and the winner ceremony, you now have the opportunity to have a look at the products of the students here behind you and the objects of the Siemens Process Automation World. And we will then continue at 5:40. Also for the online participants, you have a small break now for 20 minutes roundabout. So now we're ready for the winner ceremony. This is Professor Stock. He will announce the winners together with me. And we will start with the best presentation. And it's Next.
So maybe I would comment on that. In general, I would say we had 6 very good presentations and 6 very good concepts. I think all of the jury members said, okay, the quality of the presentations and of the teams seemed to grow the last years. So I think we are on a good way. Also, we had this time, the first time, we had the people from chemical engineering with us, So from a new technical side, it's also in the moment, I think for the next year, we will have also other people in other technical divisions, so that the student innovation lab is going to grow. And so with that, I think we will gain more, let's say, also public interests. We have already some people in the audience from outside, which are interested in. And so this is for me. I was beginning with you also in the planning of this student innovation lab, and I'm quite happy about that. And concerning you, I'm also somebody who is in the evening in the TV watching. I can understand it very well as a consumer, and I have also my problems over there. So, and also I think so the presentation was really quite nice. I'm convinced also with your product, and congratulate you and wish you the very best for that. Yeah. So, and now I think we come to the best product.
Moment. So maybe we will take the group photo now. So, and now we will continue with the best product. And it's Desoltic.
So also in the decision for the best product, the jury members voted for here and that. At the end, the majority voted for you. Yeah? So congratulations to that. Yeah? We were quite impressed also by all the numbers you could find out in the market. No? And of course, also we are convinced that sustainability in the electronic market is really a big issue. No? And also we saw the machines and so said, okay, oh, where did you all this stuff? No? Yeah.
So yeah, very thank you. Yeah, I have to thank a lot also the IAE, the Institute of High Frequency, and also the WBK, because the WBK spawns a lot stuff, and without the WBK it wouldn't be possible to build this prototype.
Okay. So, and at least I would like also a little bit to comment in general. No? I think the last years we developed this teaching unit, and I think I can say what we saw today, it was successful, and I think we will in future even more successful. What's a little bit limiting still is the transfer into reality. No? That means, so far I know, we had already one team who started really as a startup now, no? From the first SIL was it in 2019, I guess, no? Yeah. So this is one, yeah? And from the team last year, somebody was talking with me about support to make an exist approach. So maybe, or I hope that this will work out, no? And I hope we will have more teams who are willing to do the startup. No? It's also, I think I want to mention that me and probably all of us are supporting such teams if they want to do that, making to have a team master thesis on that, no? Which could be a step further, yeah, in the direction of making a real startup. And also then at the end we can use these results then for making, for example, exist proposal. No? And also I think the industrial partners, the number of industrial partners is growing. No? Also from that side is maybe in future also maybe some investment possible so that we can create even in future more startups. And I think a little bit, a colleague of mine was recently in Seattle at a conference, no? And he brought back a slide which was presented there. I think it was a European one. No? And he compared the different economic countries, or let's say areas in the world. And I said, okay, one side we have the US, no? Then we have China, and we have Europe. No? And I said, okay, the US, this we are talking about innovation. No? China, we are talking about workforce. No? Europe, we are talking about rules. No? Yeah. So I think this is at least my experience. Yeah? And I think what we should do here, and we do it of course in comparison to the very big world level on a very small level, but everything what we start is at the beginning very small. And I see we are going to grow. And so with that, I wish that we can contribute, let's say, to another vision of Europe, which is maybe also innovation. Okay, thank you.
So last but not least, the darling of the public, and it's Gecko. So now, before we jump over to the networking and eating part, we want to take a big picture of all of us outside. Yes.